Quantitative data analysis basically boils down to three main tasks. The first is to get to know what's there, effectively to describe your data. Then you need to talk about the relationships between different parts of your data. This is where we move into explaining the data. And then finally, we want to map these relationships that we see to our population of interest. And that, at heart, is really what inferential statistics is all about. Now, univariate statistics, which is what we're in for the current unit, is really focused on this first step. Univariate statistics is all about description. And univariate statistics is really just a fancy way of saying one variable. Uni meaning one and variate meaning variable. There is often a lot that one can learn simply by looking at some univariate statistics. We'll talk about intersecting two variables with each other in the bivariate unit. There are two general things that we can describe. We can describe the distribution of a variable, and we can describe the central tendency of a variable. And further, both of these things can be represented both numerically and visually. We always want to start with two key questions. First, what is our unit of analysis? And second, what is the level of measurement for the variable that we're interested in? How we go about this depends in particular on that second question, our level of measurement. So I'm going to start with thinking about how we deal with univariate distributions for categorical data. And if you recall, categorical data refer to nominal and ordinal level variables. The first thing we might look to is what's called a frequency distribution. A frequency distribution bins up the various categories or options available and counts them. And this can be presented as both raw counts or as percentages. So for example, here we have the distribution of counts for gender from some survey. Or we might use a bar chart. A bar chart is a way of putting categories on the x-axis with the counts or the percentages on the y-axis. And for certain types of data, that could be flipped, and you can put the labels on the y and the counts extending on the x, but it's basically the same thing. And there are some different subtypes, such as stacked or side-by-side. We'll get into all of that later on. A note, pie charts are basically bar charts in circular format. But as we will talk about in a later video, you should never use them. Just hold that thought if you don't believe me. Here are some examples. You can see the frequency distribution for gender already on the screen. So if we had a sample of, say, 1,285 people, we might have 720 women, 562 men, and maybe 3 who marked some other gender or who didn't mark that question on the survey. And we could also make a graph out of this. So here's the same information using the count data in bar chart form. Or we might look at something like race in the U.S. population. And this is information coming from the 2021 American Community Survey run annually by the census. And in that year's survey, we found that Americans broken out by race constitute 75.8% white, 13.6% black, and so forth and so on down the line, as you can see here. And I've also graphed that on the right so that you can see what that looks like visually. Now, if you're paying close attention here and doing a little bit of math, it is not uncommon to have our percents not quite total up to 100. If we go back to gender, in the case of gender, if we look at that closely, that actually totals up to 99.9%. That's not because there's something missing. That just is simply a rounding error. And sometimes that happens. As long as you're within a few decimal places of the 100% mark, you're probably okay. Sometimes rounding does that. In the case of race, it's actually something different altogether. We'll talk about this more later, but the short version is that the U.S. Census treats the category of Hispanic or Latino as an ethnicity, not as a race. And so technically the line for Hispanic should not be counted with these others. We'll get into some of those nuances down the road. Sometimes we might even have nominal variables that are binary, in which there are only two options. Usually that would be a yes or a no option. In that case, we can often get away with only presenting one of those options, but it will depend on what the binary variable looks like. Another type of variable that we often encounter in the social sciences are ordinal level variables, particularly for surveys that ask attitudes and opinions about different things. And we usually put these on a Likert scale. They might range from 1 to 5 or 1 to 7, or there's all sorts of different ranges we can look to on this. They behave very much like nominal variables, except that because they are ordinal, the order matters. There is now actually a ranking. And so here we can see an example from a survey that I helped to conduct several years ago in Louisiana that was asking about food usage and food access. And some of the questions included things like, how important is blank in your food purchasing? And so we asked about the importance of food quality, food cost, food being from a local source, organic food, and several other things. And the questions allowed responses that went from very unimportant to very important. So there's clearly a ranked element. And we can use a frequency distribution to easily show these data in tabular format. And here's what those same data look like in bar chart format. Sometimes we have variables that could be continuous, but we have to measure categorically. One common example that we may encounter is education. We could measure education in terms of years of education, and that is a continuous variable, but that's also often very messy. So it is more common to bucket education into 5 groups, sometimes fewer, sometimes more, depending on your need, but generally, we measure education in terms of having less than a high school diploma, having a high school diploma or GED equivalent, having some college, having a 4-year college degree, or having an advanced degree. Here's an example of a bar chart using these categories from the same survey that I just referenced. Now, education does not normally skew in this way, but it was a college town, and so that could have played into things here. In this case, we might collapse the first 2 or even 3 categories. We might do something like those without a college degree and those with a college degree. We might binarize the variable. There are different choices we might make depending upon the data and the questions being asked. Another variable that is technically continuous, but we often treat as categorical, is income. Income should really be a continuous variable. It's about the money you make. But most people are really sensitive about sharing how much money they make. In my own experience as a researcher, I have found that people are more likely to tell me about their sexual activities before they will tell me about their finances, which I find a little bit odd. So often, an income variable is already collapsed into groups. And often those groups are not perfectly uniform. This is especially true at the upper end of the range, and this is because of the way income is actually distributed. Let's turn to thinking about how we would calculate or present univariate distributions for continuous data that we're actually treating as continuous. So now we're talking about interval and ratio level variables. For a continuous variable, a frequency table just doesn't make sense. The best way to describe the distribution of a continuous variable really is visually. And there are generally 3 types of graphs that we can use. The most common of those is the histogram. A histogram shows us the range of values on the x-axis and the frequency at which that value exists on the y-axis. Histograms tell us about the shape of the data. If we think about that bar chart that we saw for education, for example, a bar chart for an ordinal variable is sort of like a proto-histogram. In fact, a histogram basically does what we just talked about with income. Don't tell anyone, but this is actually showing the income variable from that survey I mentioned. It's technically not a histogram, but it gets the idea across. What we're seeing is that we bin up the data and we count how many entities have a response in that bin. It's just that with continuous data, the bins are supposed to be uniform. We can make it large or small, and we have to do that to aggregate sets of data for the presentation. Now, the main weakness of histograms is that they aren't really conducive to comparisons. Box plots, though, are a common way of comparing distributions side by side. They are usually presented vertically, meaning now we see the values along the y-axis instead of the x-axis. Now, the trade-off here is that it loses the frequency aspect by not showing the thickness of a distribution, but you gain a lot of information. A box plot shows us the interquartile range with the median represented by the middle line and the whiskers, or those little tails coming off either end, at the nominal minimum and maximum values. Now, when I say nominal minimum and maximum, that's kind of important because it's technically not always the actual minimum and maximum. And the example here with the one on the left for college shows us a case where this is going on. Sometimes you will see little dots further out that represent outlier values. Don't worry too much about that right now. There's some math involved behind that, but for the most part, you just need to know that this shows us something about the distribution and allows us to present distributions side by side. And if you don't know what all of the terms mean that I just threw out there a second ago, stay tuned for the next video. We'll be talking about that shortly. Now, I personally think that violin plots are actually the best of both worlds and also incredibly visually aesthetic. Violin plots don't demarcate the interquartile range or the median in the way that a box plot does, but they show us relative frequencies of a distribution, similar to a histogram, and they allow us to compare multiple variables or groupings of variables side by side. While visuals of data are great, of course, they do limit our ability to carry an analysis any further, and we're going to pick up there in the next video looking at measures of central tendency.